There are different approaches we can take while explaining the probability. One is called the subjective approach. According to subjective approach, the probability is defined as the degree of confidence that a reasonable person can have in the occurrence of certain event. Mathematically, it is a number between 0 and 1 that we can assign in favor of occurrence of an event, 0 being no chance of occurrence at all, and 1 being absolutely sure of occurrence of that event. So if the event is likely to occur 50-50, then its probability would be 0.5. And another approach we take toward explaining the probability is experimental probability. This is a method of assigning probability to the occurrence of an event based on previous information. For example, if a player has won 2 games out of 5, then while that player is going to play the 6th game, what are his chances of occurrence winning the 6th game? Those will be 2 over 5 because he won 2 games out of 5 games. Therefore, his chances of winning are 2 out of 5, which is equal to 0.40. And there is still another approach that we can take toward probability, and that is objective approach. Just like any other scientific method, this way when we try to assign probabilities, we will first define few terms. The first term we are going to discuss is sample space. Sample space is the set of all possible outcomes of an experiment, and every outcome is called a sample point. And here, if we throw a cubic dice, if example is, when we throw a cubic dice, when we throw cubic dice, now cubic dice labeled with faces A, B, and C. Then what is the sample space? Then sample space S would be equal to A, B, C. These are all the 3 possible outcomes. So we list all the possible outcomes of this experiment, separate them with a comma, and enclose them with pair of brackets and name it as S. This is called sample space. Event. Every subset of the sample space is called an event. As we have defined here, the number of subsets would be 2 power n, where n is the number of sample points. So 2 power 3 in this case, which is equal to 8. So there will be 8 events. Let's list all the events. Means all the subsets of this sample space. So 5 being null set, then A, then B, then C is an event, and these are A, B, and C, the singleton sets, are called simple events because they contain only one sample point, A, B, B, C, and A, C, the last A, B, C. These are called compound events. So events with more than one sample points are called compound events. events with only one sample point are called simple events. Null set, which is also an event, is called an impossible event, and sample space itself being subset of itself is also an event, which is sure event. So remember these concepts: impossible events, impossible event. Here null set is the impossible event. Then simple events, we have defined that simple events are the events which contain only one sample point. Compound events, compound events with more than one sample point, and sure event. Sure event, these events, this sample space itself is a subset of itself, that's why it's an event, and its probability is equal to 1. What is the probability of null set? That's 0. Anyway, now these are three very important definitions for the probability. One is the mutually exclusive events. Events which cannot occur together are called mutually exclusive events. For example, if you take a look on the event, example is A, which means that when you throw a dice, the face A will turn up, and the event, let's name it as capital A, and there is another event, let's say BC, that is equal to set B. Now event A and B cannot occur together. Event A says that face A will come up. Event B says that B or C will come up. So if B occurs, then A cannot occur, and if A occurs, then B cannot occur. In other words, it means that the intersection between these two events is equal to null set, that is an empty set. So two events A and B are called mutually exclusive if their intersection is a null set. Equally likely events, events which have same chances of occurrence, are called equally likely events. And then collectively exhaustive events. So events whose union, if we take union of all the events, and that is equal to sample space, then collection of such events is called exhaustive. And one more definition before we close is the independent events. So independent events. These events are, for example, if you throw a dice and you throw a coin, throwing of a dice is denoted by capital A, and throwing of a coin is denoted by capital B. The outcome of A is totally independent of the outcome of B. The throwing of coin doesn't have to do anything with it, what is the outcome, what is the result of A. Therefore, two such events are called independent. So two events A and B, two events A and B are independent if occurrence of A does not depend upon occurrence of B. And if they are not independent, then they can be dependent events. Anyway, theoretical definition of probability is that if there are n equally likely, mutually exclusive, and exhaustive events, and m of them are in favor of occurrence of the outcome A, then probability of A is equal to m over n. And yet another approach toward defining probability is called the mathematical definition of probability. If a sample space has n sample points and m of them are in favor of occurrence of event A, then P of A is equal to m over n. For example, if you throw a dice, if we throw a dice, then what would be the sample space? When we throw a dice, the only face that can come up is 1 or 2 or 3 or 4 or 5 or 6. If event A is the even number, like event A denotes that if the even number comes up, then A is said to be true. Then which sample points are in favor of A? Then the sample points which are in favor of A are the outcomes which are in favor of A if the dice shows 2 or 4 or 6. These are the even numbers. Therefore, probability of A would be equal to 3 number of favorable outcomes divided by total number of outcomes, which are 6, and the probability would be equal to 1 over 2. If we throw a coin, then what is the sample space? Example 2. If we throw a coin is equal to head and tail. When we throw a coin, then probability of head, probability of A, where A denotes the occurrence of head, is equal to 1 over 2, where A denotes occurrence of head. So this is how we calculate probabilities. In a given question, we take the all possibilities, which are termed as n, and then the number of favorable outcomes, which are m, and then the probability of that event is m over